Hello everyone, welcome back to my YouTube channel Cloud and AI Analytics. Hope everyone is doing good. I am Vignesh and in this playlist we'll be discussing some popular Apache Spark interview question and answers. And this playlist is specifically dedicated for Spark interview questions where it consists of real-time interview questions, scenario-based questions, live coding and also the unavoidable theoretical based questions. So this playlist, irrespective of being an experienced or fresher, it will definitely help you in preparing for your interviews. So all the real-time codings, everything will be done in Google Cloud's Dataproc or else in Databricks. So without any further delay, let's get started. So the first question is difference between Apache Hadoop with Apache Spark. This is very commonly asked interview question in big data engineer irrespective of your experience. So the first difference is Apache Spark is stores data in memory, whereas Apache Hadoop stores data in local disk. And when you talk about speed, Apache Hadoop is comparatively less when you compare with Apache Spark. And Apache Hadoop is suitable only for doing batch processing, whereas Apache Spark you will be able to do both batch and real-time processing. When it comes with scheduler, like Apache Hadoop needs external schedulers, whereas Apache Spark can schedule itself. And the next thing is when we talk about latency, Apache Spark has very low latency when compared with Apache Hadoop. And inside Hadoop, there is no inbuilt interactive mode except peak and high. And Apache Spark allows recovery from partition. And when we discuss about the speed, we have already mentioned that Apache Hadoop it has decent speed, whereas Apache Spark is 100 times faster than Hadoop in memory and 10 times faster in disk. So these are the major difference between Apache Spark and Apache Hadoop. The next popularly asked question is what is lazy evaluation in Spark? So Spark is known for its lazy evaluation method. So we'll try to understand what is lazy evaluation in Spark and what are the benefits of lazy evaluation. So Apache Spark delays its evaluation till it is absolutely necessary. So Apache Spark delays its evaluation, basically doing the transformation or taking action on particular transformation. It delays till it is absolutely necessary. The lazy evaluation is known as call by need. It's a strategy that delays the execution until one requires a value. The transformation in Spark is lazy in nature. Spark evaluates them lazily. When we call some operation in RDD, it does not execute immediately. Instead, Spark maintains the graph of which operation it demands. So it means we can execute the operation at any instance by calling the action on the data. So Spark maintains a DAG graph. So whenever we wanted to execute, we can call that action on the particular data. The data does not load until it is necessary. So in other words, the execution will not start until an action is triggered. In Spark, the picture of lazy evaluation comes when a Spark transformation occurs. So what are the main benefits of lazy evaluation program? It increases the manageability of the program. It saves computation overhead and increases the speed of the system. And it also reduces the time on space complexity. And finally, it provides the optimization by reducing the number of queries. And the next question is what are the different types of SCD? So basically there are 6 types of SCD. SCD is nothing but slowly changing dimensions. In this we are not going to explore what is slowly changing dimension. Instead we will understand what are the different types of SCDs. So basically there are 6 types. The type 1 is overwrite the old data with new data. It means it will completely overwrite the data. The next one is type 2. It will create a new record with a new primary key. Then the type 3 is create a new column to store the old data. And the type 4 is create at a separate table to store the old data. And finally, type 6 is hybrid of type 1 and type 2. So these are the different types of SCDs. The next question is what is the difference between Parquet and ORC file? Why does the industry use Parquet over ORC? Can schema evolution happen in ORC? File formats available in Spark, Parquet and ORC are the type of file formats available in Spark. Apart from that, there are various other file formats like CSV, JSON, and text file. There are various other things. But why the industry prefers Parquet and ORC file? Parquet and ORC file are both are column level storage formats. So it will save the data in the columnar level. Parquet is a columnar storage format that is widely used in the industry due to its cross-platform support and better compression. Whereas ORC, it is an another column level storage, but it supports schema evolution. So if you need schema evolution, you can go with ORC. Whereas Parquet, it supports cross-platform support and also better comparison. Parquet is preferred over ORC due to its better compression and support of wider range of programming languages. Spark supports programming languages like Python, Java, Scala, and R. ORC is preferred when the schema evolution is required. The compression and in order to support different wide range of programming languages, then Parquet is the preferred one. Both formats are optimized for analytical workload and support predict pushdown and column pruning. So the next is difference between map and flatten map in Spark. So map is Spark map transformation applies a function to each row in the data frame or in the data set and returns the new transformed data set. It means function in map can return only one item. So one transformation, if it is applied to the one row, it will return at the end of the result, it will have one item. So it will be 1 to 1. Whereas in flatten map, flat map transformation flattens the data frame data set after applying the function on every element and returns a new transformed data set, but output is flattened. So here it will be one to many. So the returned data set will return more rows than the current data frame. It can return a list of elements 0 or more. It also referred to as one to many transformation function. Map, it is 1 to 1. The next and the final question of this particular video is, what is the partition in Apache Spark? This is a very commonly asked question in big data engineering. So partition refers to logical block of large distributed data set. 1000 dB, it will be like 10 GB, 10 GB, 10 GB. It will be logically distributed, and logically partitioning the data and distributing it over the cluster provides parallelism. So partitioning helps in providing the parallelism in order to break that huge data into multiple blocks and to process it. It also minimizes the network traffic for sending data between the executors. It means worker nodes. It determines how to access the entire hardware resources during the job execution. RDD is automatically partitioned in Spark. We can change the size and number of partitions manually. So these are the first 6 questions of this particular video and the playlist. Going forward, you will be able to see a lot more coming in this playlist. Please do like, comment, share and subscribe to Cloud and AI Analytics, and don't forget to click on the bell icon. I'll see you in the next video with more interesting or more review questions on Spark. Until then, it's bye from Vignesh. Happy learning.